Okay, now moving on to our last example. Okay, after this you can try some questions by yourself to apply what I just taught you. Okay, just remember, don't worry, don't understand anything, WhatsApp me, you just message me in the chat group, I will answer you, I will help you. Alright, you're not alone, together we are stronger. Okay, so let's look at example 3. Okay, how is example 3 different from our previous example? How is it different? You look carefully now, instead of line above curve, what do you have? Instead of curve above the line, now what you have? You have the line above the curve. You realize? Huh? Look here. So the first thing we need to do first, of course, is to find our limits again. What is our limit? 0 to what? 0 to what? We don't know, right? So we have to find the point of intersection, right, between the straight line and this curve y equals x squared. So that will help us to find the area of this shaded region. So to do that, I must first find the equation of this blue color line. How do I find the equation of this blue color line? Let's take a look. This is the gradient. Okay, the gradient of tell you what, I just call this point A, this point B lah. Okay, easier for me to identify. Gradient of AB equals 2. So rise over run, right? If not, you can use your y1 minus y2 over x1 minus x2. So I know my rise is 6, my run is 6. Then because it's downward sloping, it falls from left to right. That's why it's negative sign. Right? The gradient is negative. The gradient is negative 1. And then since it cuts at the y-axis at 6, right? Don't bother. I know that the equation of AB is y equals to minus x plus 6. Right? Straight away, because the gradient is negative 1, the y-intercept is 6. So to find the area of this part, right, I must first find the points of intersection. What is this value? What is this value over here? What is this value? Okay, to do that, color code in red color. So point of intersection is always what? Simultaneous equation, right? So we apply simultaneous equation. At this point where they intersect, the green color equation, right, the curve must be equal to the blue color line. So the blue color line, the equation is y equals to minus x plus 6, right? Y equals minus x plus 6. Or some of you cannot see, I write on top, y equals to minus x plus 6. Okay? The green color line, the equation, maybe I write here, right? Is y, okay, y equals to x squared, I just leave it there, right? So I equate them first. So negative x plus 6, so this x squared plus x minus 6 equals to 0. Easily factorizable. What if it cannot be factorized? Always resort to your formula method, okay? So this is 3, 2, plus minus, okay? Done. So I know x is equals to negative 3 or 2. In this case, obviously, since it's on the right hand side of 0, the origin, since it's on the right hand side of origin, it cannot be negative 3, right? It cannot be negative 3, and A. So it must be 2. So this value here is 2. So what is the area of this region, this shaded region, right? So area is equals to area of shaded region. Region is equals to, so you integrate between 0 to 2, 0 to 2. Then on top line minus below line, right? Always remember what is on top minus what is below. What is on top? Look at every point over here, right? Look at every point over here. Look at all the points. At every single point, you notice the line is above the curve at every point. Line above the curve. Only at this juncture, the line is equals to the curve. So the line is on top of the curve. So the line is negative x squared plus 6 minus the curve. Curve is x squared. dx. Okay, so we just integrate this accordingly. This is minus x, not minus x squared. Minus x plus 6, the line, minus the curve. So integrate this is minus x squared over 2, plus 6x, minus x cubed over 3. Okay, bounded between 0 to 2. Then you just plug in the values accordingly. So this minus 2 squared over 2, plus 6 times 2, minus 2 cubed over 3. Then minus, put in all your zeros, all your zeros. 6 times 0 minus 0 cubed over 3. Okay, then punch your calculator. This part, just punch your calculator, okay? I show you I'm quite good at punching calculator also. 2 square over 2 plus 6 times 2 minus 8 over 3. Oh, 7 and 1/3. So area is 7 and 1/3 square units. Okay, so I hope my three examples I'm clear enough to tell you that when you want to find the area bounded between a curve and a line, always ask yourself what is on top, what is below. Okay, always the what is on top minus what is below. That's point number one. Number two, what are your limits? Your limits are always the where they intersect, right? Your x-intercepts. So this is corresponding to the x-axis. The same thing will happen when we correspond to the y-axis. What is on top minus what is below. Okay, same thing. I'll give you more examples in the next lesson. Okay, so for now, try out the questions that I'm going to give it to you. Please work hard.